Lesson 4.8, solving a system of equations by elimination using addition and subtraction with multiplication. So in our last lesson, we started with elimination with addition and subtraction only. Elimination with addition and subtraction is good because it allows for any possible scenario, including odd coefficient combinations, fractions, and decimals, and large numbers. But so far we've used graphing, substitution, and elimination with addition and subtraction. That only works in certain situations. Graphing only works if you don't 100% need an exact answer because it won't always give you one. Substitution only works best when there's no coefficient on one of the variables, and elimination with addition and subtraction only works when the coefficients on a variable pair match. If the coefficients don't match, we can add another step, and that is multiplication. Elimination with multiplication works for all possible scenarios in a system of equation and will work to obtain an exact answer at all times. So this is the process that will always work. Okay, in order to use elimination with multiplication, we need the following. A system of equations. No other special conditions need to exist. Solving a system of equations with elimination with multiplication. Here I have two systems. Step 1, I'm going to determine what method of solving the system will work best: graphing, substitution, elimination with addition or subtraction, or elimination with multiplication. Now this graphing I'm not going to use because I don't know for sure if it's going to give me an exact answer, and I need an exact answer. I could potentially use substitution on this particular one because I do have no coefficient on these variables. So I could say, for example, x is equal to y plus 13 and do substitution, but I'm not going to do that this time. I can't use straight elimination with addition and subtraction because I don't have matching coefficients. So I'm going to use elimination with multiplication. Okay, so I'm going to use elimination, and I need to identify if a variable had a matching coefficients, which they did not. So if so, I use addition or subtraction the way we did in lesson 4.7, but if not, I determine if either variable has coefficients that are factors of one another. Okay, so what does that mean? If I look at our first system, I have 4x and x. I can turn an x into a 4x. 1 is a factor of 4. Or I can turn a y into a 2y. Looking at my second example, I have a 3 and a 5. I can't turn a 3 into a 5 or a 5 into a 3. And here I have a 4 and a 9. I can't turn a 4 into a 9. So for step 3, I'm going to multiply my equation by whatever number will turn the factor into the opposite coefficient. So I either need to turn this x into a negative 4x, or I need to turn this y into a negative 2y. Now because this is already negative, turning it into a negative 2y will make the most sense. I'm going to multiply this entire equation by 2. So I multiply every term in the equation by 2, and I get a new system, or an updated system. It's not new, it's just altered a little. Because I multiply every single term by 2, it doesn't actually change the value of the equation in any way. Now that I've got the opposite coefficients, then I can solve the system using addition. So 4x plus 2x is 6x. 2 and negative 2 cancel. 10 and 26 is 36. I divide both sides by 6, and then I get x is equal to 6. I then take my x is equal to 6 and I plug it into either equation up top. In this instance, I'm going to use x minus y is 13. So I have 6 minus y is 13. I subtract 6 from both sides. I have negative y is equal to 7. That gives me y is equal to negative 7. So my solution to this system is 6, negative 7. Now, when I look at my second example, like I said before, I cannot turn a 3 into a 5 or 4 into a 9. So now we go to this other step 3. So you have, step 3 option 1 and step 3 option 2. So if not, I determine which variable I would like to eliminate. Do I want to get rid of x's or do I want to get rid of y's? It doesn't really matter which, so I'm just going to get rid of x's. So I'm going to multiply each equation by whatever number will create opposite coefficients. So 5 and 3 will both go into 15. So I multiply this whole equation by 3 to turn this 5 into a 15. And I multiply this entire equation by 5 to turn this 3 into a 15. But I want it to be negative so that they'll cancel. So I'm going to multiply by negative 5. This is going to give me an updated system of 15x minus 12y is equal to negative 90. I got that by multiplying everything by 3. And then when I multiply everything by negative 5, I'm going to get negative 15x plus 45y, positive because I'm in negative times a negative, is equal to, and then I have 5 times 18, and it's a negative times a negative, so that's going to give me a positive 90. Now I can add the systems together. I solve using addition. Negative 15 and positive 15 cancel. Negative 12 plus 45 is 33y is equal to negative 90, and positive 90 gives me a 0. So y is equal to 0. And then I can pick either equation. Doesn't matter which, so I'm just going to pick the top one. So I have 5x plus 4 times 0 is equal to negative 30. That tells me that 5x is equal to negative 30. I divide both sides by 5, and I get that x is equal to negative 6. So my solution is negative 6, 0. So the key is to make coefficients that match. So you can either multiply one equation or you can multiply both equations in order to do that. Okay, I've got 2 more examples here. Here I have a 2x, or an x and a 2x and a 7 and an 8y. I can turn this x into a 2x. So I'm going to multiply this whole equation by negative 2 to make them opposite. So I have negative 2x plus, minus 14y is equal to 0. And I did multiply, but 2 times 0 is just 0. And then I have 2x minus 8y is equal to 22. I didn't change that one. I'll add those together. 2 and negative 2 cancel. Negative 14 and negative 8 is going to give me negative 22. Y is equal to 22. Dividing both sides by negative 22, I get that y is equal to negative 1. Plugging that in, I'm going to use the top equation. X plus 7 times negative 1 is equal to 0. X minus 7 is equal to 0, so x is equal to 7. So my solution is 7, negative 1. Okay, on this equation, I have 8 and 16 and 6 and 7. I can turn an 8 into a 16. So I'm going to multiply this by 2. That'll give me positive 16 and negative 16. So I have 16x minus 12y is equal to negative 40. I multiplied everything by 2. The other equation does not change. Add together, and I get negative 5y is equal to negative 10. Dividing by negative 5 gives me that y is equal to 2. Plugging that into either equation, I'll do 8x minus 6 times 2 is equal to negative 20. So I have 8x minus 12 is equal to negative 20. Add 12 to both sides, and I'll get 8x is equal to negative 8, which gives me that x is equal to negative 1. And so my solution is negative 1, 2. Okay, on our next examples, here I have fractions. So this one I'm actually going to take a couple of extra steps. I'm going to multiply this entire equation by 18 first to clear the fraction. That'll make it easier to figure everything else out. So I'm going to have negative 24 minus 8x is equal to 12y. And I'm going to have 18 plus, 9 goes into 18 twice. 2 times 5 is 10, so 10y. 18 goes into 18 once, so those cancel, so negative 7x. Then I'm going to rearrange so that they're lined up nicely. So I'm going to do negative 8x minus 12y. So I'm bringing this 12 over, and I'm going to put this 24 over here, so that's going to give me a positive 24. And then I'm going to have 7x plus 10y. So I bring the 7x over, and I'm going to move the 18 to the other side, so it'll become negative. Anytime you change from one side of the equal to the other side of the equal, you change the sign. Okay, so I have an 8 and a 7 and a 12 and a 10. 8 and 7 will both go into 56. So if I have to, I can use that one. 10 and 12 will both go into 60. So it's a matter of deciding, do you want to work with 56 or do you want to work with 60? Do you want to get rid of the x's or get rid of the y's? It's going to be 6 in one hand, half dozen in the other kind of situation. It doesn't matter which you get rid of. So I'm going to go ahead and do 60 because then I'm multiplying by 5 and 6 instead of 7 and 8. It's just a matter of, I think it's smaller, so to me that makes more sense. And so I'm going to have negative 40x minus 60y is equal to 120. And then I'm going to have 42x plus 60y is equal to negative 108. That's a 2. Adding these together, negative 40 plus 42 is going to give me 2x. My y's will cancel. And then 120 minus 108 is going to give me 12. Divide by 2, and that will give me that x is equal to 6. I'm going to come back to the original equation. I always go back to the very first original equations. And I'm going to use the top one. So I'm going to have negative 24 minus 8 times 6 is equal to 12y. So that's negative 24 minus 48 is equal to 12y. 48 and 24 is going to give me negative 72 is equal to 12y. Dividing both sides by 12, I'll get that y is equal to negative 8. So my solution is going to be 6, negative 8. Okay, this equation has no fractions or decimals. It just needs to be rearranged so that everything lines up. I'm going to put x's out front just because I like them better that way. And this equation I'm just flipping. I didn't actually switch sides. I rotated around. I took this and put it here, and took that and put it there. So I have an 11 and a 10 and a 4 and a 10. 4 and 10 will both go into 20. So I'm going to multiply this equation by 5. And I'm going to multiply this equation by negative 2. That's going to make this a negative 20 and a positive 20. Maybe I'll flip that. Maybe I'll make that negative and that positive. So I'm going to get 55x plus 20y is equal to 36 times 5 is 180, and that's going to be negative 180. And then I'm going to get negative 20x minus 20y is equal to 40. When I add those together, I'm going to get 35x is equal to 140, negative 140. Dividing both sides by 35, I get that x is equal to negative 4. So see, even though I have these large numbers, I still get a relatively simple solution. So don't let the large numbers intimidate you. That's a y minus 11x is equal to 36. So negative 4y minus 11 times negative 4 is equal to 36. Negative 4y plus 44 is equal to 36. I subtract 44 from both sides. I get negative 4y is equal to 44 minus 36, that's negative 8. And then that'll give me that y is equal to 2. So my solution is negative 4, 2. Okay, what I would like you to do is go ahead and pause the video and try these. This one you'll need to rearrange. Here you'll want to probably clear the fractions first and then rearrange. So pause the video, work these out, and then when you've finished, come back and see how you've done. Okay, so come check your work. Now, I chose to eliminate x in the first system and solve for y first, and then solve for x. And then in the second system, I chose to eliminate y. You may have chosen to eliminate y in the first one and x in the second one, and that's fine. If you did all the steps correctly, you should still get the same answer. You should have gotten 1, 1 for the first system and negative 3, 11 for the second.